Next, we move on to data visualization. So we begin by importing matplotlib as PLT and importing seaborn as SNS. Then we move on to like fig axis is equal to plt.subplots 2, 2, fig sizes 12 and 10. Basically, this creates like a 2x2 grid of subplots for like the multiple visualization. Then we move on to axis 0, 0, histogram, brackets df quantity, bins is 50, edge color is black, all the way to axis 0, 0, set label y label frequency. This block of code basically plots like the distribution of the quantity, like which is like the number of like the items purchased per like transaction, which this allows us to like identify patterns such as like bulk purchase or like any anomalies. Then we move on to basically printing out the unit price distribution by using the histogram, titling it as distribution of the unit price and labeling the x and y axis. Then we move on to basically plotting the total spend distribution with axis of 1, 0, histogram, df total spend, pins 50, edge color is black, ranges 0 to 100, all the way to axis 1, 0, set y label frequency. Basically, this block of code basically plots the distribution of total spend, which is like the monetary value of like each of the transaction. And this is like basically key for like understanding like customer spending behavior. Next, we move on to country distribution top 10. So country counts is equal to df.country.values.head, all the way down to axis 1 to 1 tick parameters, axis equal to x, and rotations 5. Basically, this block of code basically creates like a bar chart showing like the top 10 countries by transaction counts. Then we plot all of them together. So here's our visualization for all of these. So here we have the distribution of quantity graph. Basically what this graph shows us is like the different frequencies and the different quantities being purchased in like the transactions. And as seen over here, this distribution is like very highly skewed, with like most of the transactions involving like a small number of quantities. Next, we have distribution of unit price. Basically this graph like illustrates like the frequency of like different unit price for like the items sold. And in this graph, the majority of like the unit price are concentrated around like the lower levels values with like a steep drop off as the price basically increases. Next, we have the distribution of total spend per transaction. Basically, this graph represents like the total spend per transactions, and the distribution is basically skewed with like most of the transactions like having a very low total spend. Then we have the visualization for the top countries by transactions. So right now we have like the country with the most transactions, which is the UK, all the way down to like Australia, which is like the lowest. Then we move on to plotting the time series analysis over here. So df is equal to invoice data.dt, dt.data.values.sortIndex.plt, fig size equal to 12 and 6, all the way down to plt.show. Basically this plots a graph that shows us like the number of transactions per day and basically plots them like very chronologically. And in this graph over here, this shows like a very upward trend in the data, basically showing like the increasing transaction activity with over time. Next, we move on to aggregation features. So reference date is equal to df.invoice date.max plus time delta is equal to days is equal to 1. Basically, this sets like a reference date, which is like 1 day after like the last transaction in the data set, and this is basically used to calculate the recency of like customer transactions. Then we move on to aggregating by customer. So customer ag is equal to df.group by customer ID aggregation, all the way down to our reset index. Basically, this block of code basically groups the data by like the customer ID and calculates like the key metrics such as like invoice data, invoice number, total spend, and quantity. And these metrics are basically foundational for like the lifetime value prediction. Next, we move on to customer ags is .columns is equal to customer ID all the way to total quantity. Basically, this like renames like the aggregated columns to be like more readable names. And then we move on to customer ag is equal to average order value, which is equal to customer ag monetary divided by customer ag frequency. Basically, this line of code basically computes like the average order value, as like the average order value is like a critical metric for understanding like the customer's spending behavior and like profitability. Then we move on to basically displaying like the aggregated data and like the first few rows of this. So here our output customer aggregation shape is like 14,399 rows with 8 columns, and here's like the first 5 rows of this new data set. So we have a customer ID all the way to average order value. So yeah, next we move on to RFM analysis. So basically we create like RFM scores using like ranking. So customer ag brackets RF score is equal to PD.Q cut, customer ag recency dot rank method first, Q is 5, label is 5, 4, 3, 2, 1. Basically this line of code basically assigns scores to the customer based on their regency, and like basically the lower the regency the better it is. So like 5, which is more recent, this is better than like 1, which is like the least recent. Then we move on to customer ag F score, PD.Q cut, customer ag frequency rank methods first, Q5 is equal, and then the labels go from 1 to 5, all the way to customer ag M score, monetary score, which is equal to PD.Q cut, customer ag monetary rank methods first, Q is 5, labels is from 1 to 5. Basically this block of code basically assigns like the scores to the customer based on their like frequency and monetary values. So the higher the frequency, the better, which applies the same thing for the monetary. Higher the monetary, the better it is, as 1 is like least spending and 5 is like most spending. Then we move on to combining the RFM scores. So customer ag is equal to RFM scores all the way to customer ag R squared as type string plus customer ag F string as type string plus customer ag M score as type string. Basically this block of code basically combines like the scores to provide like a compact representation of like the customer's behavior and making it easier for us to analyze and like to segment the customers. Next, we move on to basically creating the RFM segments. So df is equal to RFM segments brackets row all the way till customer ag RF segment is equal to customer ag dot apply RF segment access is equal to 1. So basically what this block of code does is basically categorizes the customer based into like segments based on their RFM scores. So if recency is greater than or equal to 4 and frequency is greater than or equal to 4 and monetary is greater than or equal to 4 is equal to champions. And if it's greater than or equal to 3, it's loyal customers all the way down to like at risks. Next, we move on to basically displaying the RFM results by printing out RFM analysis, customer ag RFM segments of value counts, and printing out like the first 5 rows of the dataset. So here's our output for this. So here's the RMF analysis with the segments. So here's the number of people, which are like champions, which is 947, all the way down to needs more attention, which has around 298. And then here we have like the first 5 rows of this data set from customer ID all the way to RFM segment.